Hey everybody, welcome back to Mr. Fincham's Fireside Follow-Alongs, and today we're going to be reading out of our science book, that is the Teach TCI, Unit 4, Lesson 4, page 306, How Do Shadows Change During the Day and Year? So, as always, for the science readings, you are going to create a graphic to show what you learned. You can use Seesaw, Keynote, Pages, any other, even a blank sheet of paper, anything you'd like for this assignment. You're going to create an image that represents what you learned today. And you need to have 3 things to go along with your image. Here's the first one. A title that represents the overarching main idea of what you read. Number 2, 4 key facts or quotes from the text in your image. And the third one, include an image either drawn or a graphic you obtained somewhere else. So remember, the point of this is to show your creative side. Get creative with it. Those of you who have sent me your science work, I've enjoyed looking at it. I hope to see some more this time around. So we are going to start off with page 306. All right, first paragraph. If you observe shadows outdoors throughout the day, you will notice that they change in 2 different ways. You would discover that the length of the shadows changes and that the direction the shadows point also changes on a daily basis. Cultures throughout history have used these patterns in different ways. Here is a little check your understanding activity. Notice how the shadows for everybody is on the left side of them, right? Anytime the shadows are on one side, that means the sun is on the opposite side. So we're going to go to page 307. And again, I'm going to click that little purple star right here for the main ideas. Notice how these are highlighted. Helps you get out those important ideas from our text. So, number 1, shadows follow a daily pattern. Notice the image right here. This is the shadow pattern. When you're outside, you might notice that your shadow changes. It might be short or tall. It might be in front of you or behind you. Why does your shadow change? A shadow is an area of darkness created when an object blocks light. Shadows can form where any light source is blocked. Shadows formed by the sun change in patterns. And here's the change in the patterns. So notice that wherever the sun is, on the opposite side is the shadow. Sun's over here, opposite side, except for noon, because noon is when it's at its highest. Third paragraph. If you watch the shadow of a tree during the day, you will see that it changes length and direction. When the sun rises, the shadow is long and points mostly toward the west. As the sun rises higher, the shadow gets shorter. At around noon, it is very short, and at the base of the tree, and in the afternoon, the shadow gets long again. But this time it points mostly toward the east. Just before sunset, the shadow is about as long as it was at sunrise. The length of shadows follows this pattern of changes each day. Recall that even though the sun seems to change positions, it is not actually moving. The pattern of changes of a shadow is caused by the sun's apparent position. Shadows are long when the sun is low in the sky. As Earth rotates, the sun moves higher in the sky, and shadows continue to get shorter until the sun is at its highest point in the sky. At this time, shadows are shortest because the sun shines straight down, or almost straight down, on objects. In the afternoon, the sun moves lower in the sky, and the shadows get longer. The direction that a shadow points also depends on the sun's apparent position in the sky. Shadows always point away from the sun because the object causing the shadow is always between the shadow and the sun. So think of it this way. If you and a friend have a flashlight, if they are pointing the flashlight at your chest, then the shadow that the flashlight is causing is going to be coming off of your back. Okay? If your friend with the flashlight shines the flashlight at your back, the shadow is going to be coming off of your front. And if your friend was pointing the flashlight down on top of your head, directly above you, the shadow would be very short, but it would be kind of around your feet. Okay. And here is a little graph about how long the shadow is. The shadow, the lower it is in the sky, the longer the shadow. And here is a little graph that you guys can fill in the data here. Okay, and we are going to go to the next page. This is page 308. Again, I'm going to click that purple star. Oh, none on this one. Okay, number 2. Shadows follow a yearly pattern. You can easily see the daily patterns of shadows by looking outside several times a day. But seeing yearly patterns is not as easy. You have to make observations for a whole year before you can see the pattern repeat. To see this pattern, you must observe the shadow of a stationary object at the same time a day for a year. So here is a picture in the summer at 10 a.m., and here's the shadow. In the winter at 10 a.m., notice the shadow's different. What you guys can do as well, if you have a basketball hoop, or if you have maybe, I'm trying to think here, like a light post outside your house, or maybe even your mailbox, bring some chalk and trace the shadow at 9 or 10 in the morning, and then trace it again at 5 or 6. Notice the difference of the shadow. If you watched a shadow caused by the sun for a year, you would see 2 changes. One change is that the length of the shadow changes with the seasons. The other is that the direction that the shadow points changes. During the summer, a shadow is shorter than it is in other seasons. If you observe a morning shadow, you will see that it points mostly to the west. If you observe an afternoon shadow, you will see that it points mostly to the east. During the winter, a shadow looks different. It is longer than it is during other seasons. It also points in a different direction. At all times of the day, it points slightly more towards the north than it does during the summer. Some ancient cultures used the yearly pattern of shadows to track the seasons. For example, historians believe that the Maya used this pattern in El Castillo, a pyramid built for the god Kukulkan. At certain times during the spring and fall, the sun hits the steps, creating a shadow on the pyramid. Many historians believe that the shadow was used to mark important times during the spring and fall. The Pueblo also built monuments that used sunlight and shadow to help track the seasons. And here is a check your understanding. Notice here, remember our Earth is on an axis, it's tilted, right? So depending on the season, the sun appears as if it's in a different position in the sky. So the blue line here, see the blue line? Shortest day of winter, here's the sun. And then you see the blue shadow. It's the longest. It's the lowest. The sun is the lowest here, and it has the longest shadow. Now, day and night equal. So here's the pink line, and then notice the pink shadow. The higher up you get in the sky, the shorter the shadow. So the red line, the longest day of summer, it's the highest in the sky, shortest shadow. And there's there's 5 questions here for you guys to do to check your understanding. And here is where you will label different parts of the diagram. Go on to the next page here. Page 309. Click that main ideas tab. Okay, so here is a sundial. This is actually what we base clocks on. This is how we invented clocks. Depending on where the sun is in the sky, it casts a shadow, and that tells us roughly what time it is. Number 3. Using shadows to measure time. If someone asks you for the time, you would probably look at a clock or a watch to find out. But telling time was not as easy before clocks were invented. So how did ancient cultures keep track of time? Many ancient cultures used a sundial to track time. A sundial is a tool that uses the shadow cast by an object in sunlight to keep track of the time during the day. The oldest known sundial was found in Ukraine and was made in 13th century BCE. Whoops. Next paragraph. Sundials come in different shapes and sizes, but all have 2 parts. One part is a thin stick or wedge that casts a shadow. The other part is a base with marks on it. The marks show time intervals. The marks are spaced so that the time needed for the shadow of the stick to move from one mark to another is equal between all marks. Many modern and ancient sundials have 12 marks that divide daytime into 12 pieces. But recall that the length of daytime changes with the seasons. So the hour marks on sundials are not the same length throughout the year. For example, during summer, it might be daytime for 12 hours, so each mark on the sundial would represent 1 hour. But during winter, each mark might only represent 45 minutes. Not all sundials have 12 marks. For example, the Pilgrims used a sundial with only one mark, the noon mark. The sundial was hung above a door or a window. When its shadow reached the mark, the Pilgrims knew that it was noon, or about the middle of the day. And here is a different kind of form of sundial. This one is like in a bowl shape, from Seoul, South Korea. Kind of cool, huh? Here's another. So here's what you're going to do down here. Explain the parts of a sundial and how it works. Include these terms in your explanation. Sundial, time, shadow, wedge, base, and time intervals. And this is something that you guys can do at home. You can even, plant a stick in your yard or somewhere near the street and trace the shadow and then come back to it and notice how the shadow moves. Go to page 310 here. Okay, I'm going to click that purple star. Number 4. Shadows point in different directions in different places. You have learned that the sun seems to move across the sky. The direction that your shadow changes, or the direction that your shadow points changes. But there is another factor that affects which direction it points. Location. You learn that at noon, your shadow is very short. It is short because the sun is nearly straight overhead. So you cast a shadow almost straight down. But it is not quite straight down. Your shadow points a little bit in one direction. Does it always point in the same direction? The direction that your shadow points changes in a pattern based on where you are on Earth. It is easiest to see which direction it points at noon. How north or south you are on the Earth determines your shadow's direction. If you are on the northern hemisphere, the sun will seem to be slightly to the south. Since shadows always point away from the sun, your shadow will point north. If you are on the southern hemisphere, the sun will be slightly to the north, so your shadow will point to the south. An easy way to think about this is wherever the sun is, the shadow is going to be the opposite direction. Obviously, unless it's above your head at noon, but that's kind of the golden rule. So if the sun rises in the east, what's the opposite of the east? West. So that's where the shadows will be directed. If the sun is setting and is in the west, which way will the shadows be directing? To the east, the opposite, right? Next paragraph. Near the equator, the sun is very close to straight overhead in the middle of the day. If you are on this part of Earth, your shadow will not point noticeably north or south. If you stay mostly in a circle around your feet, or it would stay mostly in a circle around your feet. So the farther you are from the equator, the more north or south your shadow points. And here is, you're going to complete the speech bubbles for each person. Okay, and we're going to go to the last page. All right, so this is the summary. Lesson summary. How do shadows change during the day and year? Number 1. Shadows follow a daily pattern. When a shadow is caused by the sun, it follows a daily pattern of changes. The length and the direction that the shadow points change. These changes are caused by the apparent position of the sun. An object's shadow is shortest at noon, when the sun is directly above. As the sun moves in the afternoon, the shadows get longer. Shadows follow a yearly pattern. Shadows caused by the sun follow a yearly pattern of changes. Throughout the year, their length and the direction they point change. In summer, shadows are shorter than shadows in winter. In the summer, shadows point to the east and west. In the winter, shadows point more north than in other seasons. Number 3, using shadows to measure time. A sundial is a tool that uses a shadow's pattern of changes to keep track of time during the day. All sundials have 2 parts. One part is a thin stick or a wedge that casts a shadow. The other is a base that marks on it that represents time intervals. Because the amount of daylight changes with the seasons, the intervals that the marks represent also change. Number 4. Shadows point in different directions in different places. The direction that your shadow points at noon depends on where you are. In the northern hemisphere, your shadow would point more north. In the southern hemisphere, your shadow would point more south. Near the equator, your shadow would not point very north or south. And then here is a short vocabulary. You're supposed to drag and drop the vocabulary to each definition. So, that's it for shadows. And I'm going to just read quickly your reading assignment or your reading task for today's reading assignment. And again, these are going to be on the ELA questions and tasks section of your newsletter. So after reading the assigned text for the day, you will create a graphic to show what you learned. You can use Seesaw, Keynote, Pages, other graphics or apps, software, or a blank sheet of paper for this assignment. You will create an image that represents what you learned today in your science reading. Items you have to include in your graphic are, number 1, a title that represents the overarching main idea of what you read. Number 2, include 4 key facts or quotes from the text in your image. Some students like to make these the border of their drawing. And number 3, include an image either drawn or a graphic you obtained somewhere else. So you're allowed to include any additional items you'd like. The point of this activity is to use your creative side to show what you learned. So thank you for those of you who followed along and have been submitting your thoughts on our readings and your questions. I appreciate that a lot. That is it for me today. I will talk to you guys soon. As always, feel free to join my office hours, shoot me an email, write me on Seesaw, leave some comments in the section below. Anything that you guys want to share or have questions about, that'd be awesome. Thank you guys so much. See you soon. Bye-bye.